Our first design was a delta wing based design chosen mainly out of convenience. From our perspective, a delta wing design seemed like the easiest one to replicate for beginners as it was all solid pieces cut from the same board of foam. We added a top layer for aerofoil and had slanted cutting of the foam for aerodynamics. It had a big surface area in order to distribute the weight of electronics and the plane across a larger surface with a rudder placed in the center. It had a V-shaped rear end to try and deviate from the usual delta wing design for uniqueness, and it was slightly similar to a moderately swept wing. We felt that the first design was too heavy to fly, so we decided to make it lighter by cutting the aerofoil layer off. Eventually, we decided to scrap this design due to concerns over the propeller being too small to support its large frame and weight for proper flight.
The second design is a triangle-shaped plane. Similar to the first design but smaller and lighter because the first plane was unable to move forward or lift itself up. Rudder was kept in the same position. Changed the shape of the design to a triangle, as opposed to a moderately swept delta wing. Although it was lighter, the small surface area made flying it difficult as weight was distributed across a smaller surface area.
Design was an entirely new one chosen after research due to the lack of flight of our first two designs. It took on a conventional straight-wing design that was smaller and lighter than the previous design as we felt that the propeller was too small and that the previous plane was too heavy. We eventually scrapped this design as it was too small to generate sufficient thrust and lift to counter the weight of electronics. For our fourth design, we made a delta wing-based design similar to our first one. We changed it back because of the advice on shop owners that our third design would not be able to fly and that the small propeller could fly a plane with a very big wingspan. We also realized that the first design was optimized for flight but was too large. This fourth design has rudders on the tip of its wings instead of a rudder in the center of a plane, like in the first two designs.
For control and stability, firstly we have the elevons. These are rectangular shaped with the same thickness as the plane itself. It will help control the direction of the plane, allowing it to move up, down, left and right. We also have a brushless motor. This will help spin the propeller attached to it so it will create a forward thrust and produce lift. For us, this rotates anti-clockwise because of the position it is in on the plane. We tested its airworthiness by letting the frame glide by itself, the entire plane including electronics without the motor turned on to glide, and the entire plane with the motor turned on, all when thrown. This was done numerous times both indoors and outdoors in open areas. We also checked to see that the direction of thrust was also correct by turning on the motor and holding the plane in place.
Our current design uses a delta wing design, which typically have a triangular pointed tip that pierces the air, which is bolstered by the seamless shape of the plane that allows for streamlined motion. Center of gravity of the frame was determined so that the position of electronics could be optimized to ensure weight was as evenly distributed as possible. A 3-inch propeller was chosen as it was deemed capable of supporting our plane, which has a 50 cm wingspan. Side rudders were also added to help with airflow for smoother flight.